In this presentation, we will be looking at the paper Prediction of Muscle Fatigue Using Force Myography, a Preliminary and Feasibility Study, authored by Pongavanam Palani, Siddhant Panigrahi, Avinash S. Pramod, Ashokan Tondiyat from the Department of Engineering Design, IIT Madras. Muscle fatigue, it is the reduction in the force producing capacity of muscles. It affects activities of daily living and hence it needs to be addressed. It can be sensed using electromyography, sonomyography, acoustic myography, near infrared spectrum, and the new sensing module, the force myography. In this study, we are going to perform a comparative analysis between the existing gold standard EMG and force myography. A parametric evaluation between the two is performed. This is the experimental setup where the participant is asked to perform wrist flexion extension over a period of time. Here we acquire EMG and FMG. The EMG is acquired using the advanced technologies EMG sensor and the FMG is acquired using iScan sensing system from TechScan. As can be seen, this is the EMG sensing system. The muscles that we are interested are biceps brachii and extensor carpi radialis, which are part of the EMG sensing module, and the flexor carpi ulnaris as part of the FMG sensing module. Here we can see the pressure sensor output from the iScan display, that is the part of the maximum voluntary contraction and the wrist flexion extension. We can identify that there is a straight line which is found here, and here we can see that it extends between the proximal and the distal end. So this is the MVC peak and the wrist flexion extension peak showing maximum contraction. Higher pressure is found at the proximal end during wrist flexion, while the same is present at the distal end during wrist extension. The EMG is analyzed using median frequency parameter, where it is an indicator of fatigue stage. In our experiments also, we have achieved muscle fatigue, and this can be seen using the median frequency indicator. This is found for the biceps brachii muscle and also the extensor carpi muscle. The FMG is analyzed using two parameters, variance and mean, which are found to increase between the rest and fatigue state. In order to identify if there exists any relationship between the two signals, we can estimate the linear correlation coefficient between the two. The muscles FCU and biceps brachii have 0.1410 as a correlation coefficient. It shows that there is no correlation because the biceps brachii is not involved in wrist flexion extension, whereas there exists negative correlation between FCU and ECR, which are agonist and antagonist muscle in the wrist flexion extension activity. Hence, FMG can be used to predict muscle activity. Concluding, the median frequency of EMG, which is an indicator of muscle fatigue, is found in the experiments 2, showing the existence of muscle fatigue. We perform a comparative analysis between the two, showing the prospect of FMG in muscle activity evaluation. Limitations of the study include the number of participants and the sensing film used. So if this sensor is developed with an increase in the number of sense cells, then this can be used in the armrest design, where we can reduce surging fatigue and also increase the accuracy of surgery execution. If we are able to confirm the shape of the sensors, then the FMG can be used in the actuation control of exoskeleton. Thank you.